first part that's important about improving your research efficiency is your measurements of productivity. Basically, the importance of measurement of productivity is, when you're in something like manufacturing, you can measure productivity by, say you're making tractors, by the amount of tractors that are produced. But it's different when we are speaking of the science fields. You can measure by reports published, technical journal articles published, technical lectures presented, patents received, prizes or awards received, the number of new products developed, and the importance of the results to humankind and your company. Keep in mind that these are all fallible, because even though you can do all those things, they can be very mediocre as well. And in improving productivity, it's important for a scientist to have the equipment and supplies that he or she may need. So we can say that a scientist is being productive by ordering necessary equipment and supplies, acquiring knowledge in the project area, developing competence also in the project area, doing your research, everything that we've been doing to prepare for our reports, developing a method to do your research, testing your equipment, designing special equipment if necessary, construction of special equipment, meaning putting together the equipment that you designed or anything that you may have ordered, conducting measurements, creative thinking, preparation of reports, and construction of a prototype. Developing competence in the project area. You should always seek assistance. I know we all have mentors, so we all go to our mentors, but don't just rely on your mentors. Consult librarians, colleagues, shop mechanics, designers, and other useful resources. So don't just use the librarian. Take your time and actually do your own research as well. Be aggressive. That is a very important part of being successful in a science career. Work and practice after hours. It's very important that we don't just limit our success to being in the laboratory or in the library. But when you go home, instead of watching that movie, practice your craft. Seek advice and ask questions. Ask as many questions as you possibly can. There's no such thing as a foolish question in the field of science. Equipment. It is imperative to calibrate your equipment. We all know the importance of calibration, right? Okay. When waiting to receive or ordered equipment, continue to acquire knowledge on the subject area. Continue to do research. A lot of scientists have multiple projects going on at once, so that when you're waiting for equipment from one place, you can be working on your next project. Consult with others who are knowledgeable about the equipment, such as we have the mechanical engineer that's here. What's his name? Yeah, that guy. Yes, we can talk to him about the machinery because he knows all the intricacies of such. Lease equipment if one isn't available to purchase equipment needed. So if the person in charge is telling you that you can't afford to buy the equipment, look into leasing or renting the equipment that's necessary. Preliminary experimentation. Give an opportunity to adjust the equipment if needed. Look for subtle false information which measurements may give. Work out all the bugs to prevent costly mistakes, and most importantly, prevent hazards to personnel. That's first and foremost in any field of science or engineering, is to prevent the hazards to personnel. Secondary, preventing costly mistakes, depending on where you are, of course. Final experimentation. Be on an unusual alert for subtleties. This means we don't just look for subtleties, but we're on a very heightened alert for those subtleties that may come in our measurement, that may come in our equipment. We also look for anomalies. This may need, I'll go to the next one. Look for side effects that may lead to interesting phenomena. That's important when you're looking for anomalies and the interesting phenomenon, because this could lead you to another research project or another area within your project of research. The ability to note small effects is often the difference between a good scientist and a careless one. And we're all working to be good scientists, so we cannot be careless in any part of our research. Early reports. It's nice to be able to start an early report. You can give a description of previous work in the research area. That's kind of what we're doing here by doing our reports. We're kind of just giving that description of the previous work in this research area, We're describing our equipment and materials needed as we learn the equipment and materials needed for our research to carry out the experiment. Procedures used can be written up and they can be changed when necessary. As you move on, your procedures should change because as we see these interesting phenomenon or these anomalies come into play, it's very important that we adjust our procedure as such. Think about the requirements of the report. This is one way you may check for things that would be otherwise overlooked. And it's one thing that's very important, and that is otherwise be overlooked. It's very important that we as careful, good scientists do not overlook any of these what may seem to be small anomalies, okay? In conclusion, there is no foolproof way of determining research productivity other than lack of contribution to the scientific community. It is very important for all of us to contribute to the scientific community. That's even what we're doing here in our REU program. We're contributing to the scientific community, and that's why it's very important, again, that we are not careless even at this undergraduate level. One must follow the scientific method carefully to be considered as a useful scientist or engineer. You can be a scientist or engineer, but if you're not contributing to the scientific community, why are you? Thank you for your time. Are there any questions?